Hello, welcome back to our NLP Basic series. In the last episode, we saw the introduction to NLP and you even executed a simple script that did a minimal pre-processing for you. Today, we'll be diving deep into text pre-processing, starting with the very first step, tokenization. If you're new here, I'm Arthi Rajendran, a data scientist with over 6 years of experience. I started from a non-technical background myself, so I know the struggle of trying to learn AI basics. That I'm here to make these concepts fun, example-oriented, and super easy to understand. So hit that subscribe button and let's jump in. Now, tokenization might sound technical, but it's just a fancy way of saying, let's break text into smaller, more meaningful chunks that a computer can understand. So why this is important? Well, think about it. When we read a book or a sentence, we already know how to split words and understand the meaning. But for a computer, text is just one giant stream of characters. Tokenization is how we teach it to split that stream into useful parts. Let's take a very simple sentence. Harry was walking quickly. To us, this is clear. But to a computer, it's just Harry Walking. You get the idea. Tokenization takes the sentence and breaks it into Harry was walking quickly. Each of these is a token. Tokens are the building blocks of NLP. Without them, we can't count words, analyze sentiment, or even train models. Think of it like Lego bricks. You can't build a house if you don't first separate the individual pieces. Tokenization gives us those bricks. Now, tokenization isn't just one thing. There are different levels depending on how fine-grained you want to go. For example, if you want to break down the sentence into words, so this is the most common tokenization technique called word-level tokenization. We break sentences into words. For example, Harry was walking will become Harry was walking. So it becomes 3 tokens. There is sub-word level tokenization. This is useful for complex languages or for reducing vocabulary size. For example, the word walking becomes walk and ing, 2 tokens. Or unhappiness becomes unhappiness, 3 tokens. Why does this matter? Because new or rare words can be broken into known pieces. Next, we have sentence level tokenization. So instead of words, we split text into sentences. For example, Harry loved magic, Hermione loved books becomes 2 tokens, each a complete sentence. So depending on the task, we choose the level of tokenization. Let's see tokenization in action with a simple Python code. We'll use NLTK, a very popular NLP library, and from it, we'll be downloading a specific resource called punk. So this will help us in tokenizing the sentence. For example, over here, we give Harry was walking quickly, but Hermione was far behind. So this is the sentence that we've assigned to the variable text. Now, using NLTK and then the word tokenize module, which will help us in kind of like tokenize that specific sentence into different words. And then we use send tokenize module, which will help us in breaking down the whole, the 2 sentences into a couple of sentences. Now, when we run this, we get the word tokenizer, which splits it into Harry was walking quickly. You get the whole idea. It splits it into different words. And then the sentence tokenizer gives us the whole thing. Harry was walking quickly, but Hermione wasn't far behind. Because this is one whole sentence, and because we do not have a full stop or a sentence separator in the actual sentence that we've given it. Notice how punctuations like commas and periods are also treated as tokens. That's useful sometimes, but not always. And in later modules, we'll learn how to clean this up as well. Let's try another example with multiple sentences. Paragraph equals Harry loved magic, Hermione loved books, Ron loved food. So we have 3 sentences here in this example. Now, let's try the send tokenize on this specific example. Now, so the send tokenize would split it into different sentences. And then further, in the next step, we are going to use word tokenize, which splits these split up sentences into further word tokens. So you can see how powerful this is already. Suddenly, text isn't just a big blob anymore for the machines. It's structured data. Tokenization isn't always this straightforward. We have a little contractions. For example, the word don't, D-O-N apostrophe T, should it be D-O-N apostrophe T? And should these be two tokens or don't as a single token? It varies from scenario to scenario. We have hyphenated words, state of the art. So is it one word or is it four? Languages. In Chinese or Japanese, there are no spaces between words. Tokenization there is much harder. That's why tokenization libraries and models are constantly improving. So, to wrap up, tokenization is splitting text into smaller pieces called tokens. Tokens can be words, subwords, or sentences. This step is the foundation of NLP. Without it, we can't analyze or model text. We also saw how to tokenize text in Python using NLTK. In the next episode, we'll go deeper into cleaning text, removing unnecessary words, and reducing words to their base forms with something called stemming and lemmatization. So stay tuned, hit that like button, and also subscribe if you haven't already. I'll see you in the next episode.